So looking at the first problem, it says the function f of x is quadratic with solutions to f of x equals 0 being -2 plus 3i and -2 minus 3i. Which of the following graphs could represent f of x? So we have a lot of math notation in here. This we know means y equals 0. So we're looking for the roots. And the roots are imaginary numbers. Now we can't really identify where they are on the real number line, which is like the x-axis. But we do know if we have imaginary roots, the graph does not touch the x-axis, so choice 2 would be correct. Looking at the next one, we see something else about imaginary numbers. I see nothing imaginary about this problem. It looks like a normal equation to solve, but I'm just going to start out solving it, and this is a key that I'm probably going to have to use quadratic formula. It's going to become a quadratic, and I'm probably going to get imaginary roots from a negative in the radical. So we'll start to solve this one. X squared plus 7x equals -3x minus 24 minus 4. So we have x squared plus 7x equals -3x minus 28. We're going to set it equal to 0, so we're going to bring the numbers over, keeping the x squared positive. And we end up with the equation x squared plus 10x plus 28 equals 0. Now, if I did a quick graph of this quadratic, I would see that I have imaginary roots. So I'd see a graph similar to this, maybe not in the same location, but it doesn't cross the x-axis. So that's nice because we know we're on the right track towards getting imaginary roots. My quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. So my a, b, and c values, a is 1, b is 10, c is 28. At this level, most people don't plug in the x's in quadratic formula. They don't make that mistake, but just, it's been a while, so be careful. Just the numbers go in. So make sure you have your -10 and only your -10 in parentheses there. Minus 4 times 1 times 10. So that's just plugging in those values. We always type in this part, which is the discriminant. We're expecting it to be negative, and I should have also written this before, so 2 times 1 on the bottom. So we're going to type in that discriminant, see what we get. We don't type it in with the radical because we might have to simplify the radical. So that's going to be 100, and I plugged in the wrong number here. Sorry about that. So I plugged in a 10, but I needed to plug in a 28 here. Okay. So kind of what clued me into that, I was expecting a negative number, and that wouldn't give me a negative number if I'd had the 4 there. So just kind of, everybody makes mistakes, and think about what you should be getting in the problem, and you can often catch your mistakes. So square root of -12, I'm just going to write that up here, is -4 times 3. So that's going to be 2i radical 3, because the square root of -4 is 2i. So I get 10 plus or minus 2i radical 3 all over 2. Now, when we're simplifying radicals with quadratic formula, or just anytime we have a binomial, 2 terms over a monomial, we need to look at all the terms. So the common factor between 2, -10, and 2, the coefficients of each term is 2. Now, to write this in a plus bi form, I'm just going to move the page down a little bit so we have room first. I need to have the real number. In this case, the denominator went away, so my real number is just -5 over 1, which I don't need to write, plus or minus, then I want the coefficient of the imaginary number, so that's my b, and then I. Sometimes we have fractions in this a plus bi form. Just make sure you put them only with the 2 numbers, and then you put the I at the end. Looking at the next one, it says use factoring to find all values of x that solve the equation f of x equals 15. So we can think of this kind of like a system where we have y equals this and y equals that. So we're going to set the equation equal to 15. So we're going to set f of x equal to 15. We're going to set it equal to 0 by subtracting the 15 over. So that's going to give me plus 21 equals 0. Now we could use quadratic formula for this, but it says I have to solve by factoring. So we're going to assume this is factorable. I have a number greater than 1 in the front, so I know I need to bring these 2 numbers together, and that gives me 42. So I'm trying to find numbers that add up to negative 13 and multiply to 42. And it's a super common error to go straight to this step and say, oh, I know those numbers. That's negative 6 and negative 7. But remember, we have this 2 in the front, so there's no way that x times x is going to give me 2x squared. When I bring the numbers together like that, when a is greater than 1, I have to split the middle. So I'm going to erase what I wrote, which was not correct. And I'm going to split that middle using the negative 6 and the negative 7 and splitting the negative 13x up into negative 6x and negative 7x, setting up for grouping with my 4 terms. So I'm going to write this over on the side. GCF of the first 2 is 2x. GCF of the second 2 is negative 7. And if I'm confused, do I take out negative or positive 7? I want to create an x minus 3, and taking out negative 7 will get that done. So then the common factor is now x minus 3, and I have 2x minus 7 left, giving me for my roots 3 and 7/2, which is 3.5. I graph it. The function should pass through. If I graphed f of x and y2 as 15, that's where they should intersect at those x values. They're not asking me to find the y values, which would be 15 because it says y equals 15. We're just finding the values of x. So last question on this page. We have an imaginary, it starts with imaginary numbers, and we want it in that a plus bi form. Now, just a hint, you can type these in the calculator. You should get the correct answer. I might do that in the beginning. And when I look at this one, it's short answer, so I do have to show my work. But I could at least know what answer I'm aiming for. So I'm going to distribute the first 2, giving me negative 10 plus 35i plus 2i minus 7i squared. Okay, so 7i times 1i is, or negative 7 times 1i, negative 7i times 1i is negative 7i squared. Now we'll do the second set of distributions. So I have plus negative 8. I'm just going to erase that. I don't like the plus negative. I'm just going to write it as minus. So I have minus 8 plus 16i minus 3i plus 6i squared. So from this point, there's a couple different directions I could take. I'm actually going to deal with the I squareds first. So each of these I squared is equal to negative 1. So I'm going to replace that with a negative 1. So right now, just to write it one more time, which is not necessary, I'm going to combine a couple things together. So that gives me a 37i. Negative 7 times negative 1 is positive 7. Over here, then I have minus 8. I'm going to combine this because it's right next to each other. Plus 13i, and 6 times negative 1 is negative 6. So now I can further combine negative 10 plus 7 minus 8 minus 6. If I combine those together, I'm going to get negative 17. And then from there, 37i plus 13i is 50i. So just for a review, the 4 powers of I that we work with, I to the 0 is 1, anything to the 0 is 1, anything to the first is itself, I squared is negative 1, and I cubed is negative I. And they follow this pattern, so I to the 4th would be 1, I to the 5th would be I squared would be negative 1, and I to the 6th would be negative 1, I to the 7th would be negative I, and the pattern continues through.